In this video, we will see how you can create your own tokenizer from scratch. To create your own tokenizer, you will have to think about each of the operations involved in tokenization, namely the normalization, the pre-tokenization, the model, the post-processing, and the decoding. If you don't know what normalization, pre-tokenization, and the model are, I advise you to go and see the video link below. The post-processing gathers all the modifications that we will carry out on the tokenized text. It can include the addition of special tokens, the creation of an intention mask, but also the generation of a list of token IDs. The decoding operations occur at the very end, and it will allow passing from a sequence of IDs in a sentence. For example, you can see that the hashtags have been removed and the tokens composing the word today have been grouped together. In a fast tokenizer, all these components are gathered in the backend tokenizer attribute. As you can see with this small code snippet, it is an instance of a tokenizer from the tokenizer's library. So, to create your own tokenizer, you will have to follow these steps. First, create a training dataset. Second, create and train a tokenizer with a transformer library. And third, load this tokenizer into a transformer tokenizer. To understand these steps, I propose that we recreate a BUT tokenizer together. The first thing to do is to create a dataset. With this code snippet, you can create an iterator on the dataset Wikitext2Row v1, which is a rather small dataset in English. Perfect for an example. We attack here the big part, the design of our tokenizer with the tokenizer library. We start by initializing a tokenizer instance with a word pieces model because it is the model used by BERT. Then we can define our normalizer. We will define it as a succession of two normalizations used to clean up characters not visible in the text, one lowercasing normalization, and two last normalizations used to remove accents. For the pre-tokenization, we will chain two pre-tokenizers. The first one separating the text at the level of the spaces, and the second one isolating the punctuation marks. Now, we can define the trainers that will allow us to train the word pieces model chosen at the beginning. To carry out the training, we will have to choose a vocabulary size. Here we choose 25,000. And we also need to announce the special tokens that we absolutely want to add to our vocabulary. In one line of code, we can train our word pieces model using the iterator we defined earlier. Once the model has been trained, we can retrieve the IDs of the special class and separation tokens because we will need them to post-process our sequence. Thanks to the template processing class, we can add the class token at the beginning of each sequence and the set token at the end of the sequence and between two sentences if we tokenize a pair of text. Finally, we just have to define our decoder, which will allow us to remove the hashtags at the beginning of the tokens that must be reattached to the previous token. And there it is, you have all the necessary lines of code to define your own tokenizer with the tokenizer library. Now that we have a brand new tokenizer with the tokenizer library, we just have to load it into a fast tokenizer from the transformers library. Here again, we have several possibilities. We can load it in the generic class pre-trained tokenizer fast, or in the BERT tokenizer fast class since we have built a BERT-like tokenizer here. I really hope this video has helped you understand how you can create your own tokenizer, and that On that, you are ready now to navigate the Tokenizer library documentation to choose the components for your brand new tokenizer.